I think that's pretty widely recognized now as a sixth sense. So see, you can see it, smell it, taste it, touch it, or hear it, but there's other ways that human beings interact with the external world. One is proprioception. Proprioception is the ability that you have to tell where your body's location is in space, right? So like right now, I can't see my hands. I'm not feeling anything with them. I'm not using my sense of touch. They're just hanging out in the air. But I know that my hands are behind my lower back right now. Yeah. Now I know that my left hand, I'm gonna close my eyes. I know that my left hand is behind my head, right? How do I know that? That's not because I see it, smell it. I hope I don't smell it, taste, touch it, or hear it. I'm not doing any of those things. But nevertheless, I can tell where my body is in space. This is the kind of thing that enables like Odell Beckham Jr. Go look at the, I don't know if they have a name for that catch that he made, where he's like, on the sidelines, reaching backwards and catches the ball at the point, when he's like looking this way, and it's like behind his head, right? The ability that a human being has. I hurt my back. This is, man, they're getting old such. Like, you hurt your back. What did you do? I bent over. That's what I said. Like, anyway, the ability that human beings have. He's tracking that ball with his eyes, of course. He is, but then he is going over his head and behind his head, and he has his hand out behind him and catches the ball. Right? He knows where to put his hand. Right? That's remarkable. The reason why human beings are able to, that's the ability that human beings have to tell where their bodies, where their limbs are in space is called proprioception. Part of the reason I know this is because my dog, who is your TA, by the way, he is the teaching assistant for this course. He will actually be grading all of your assignments. He just paw print. That's, yeah. So if you get a paw print, that's an A. He's around here somewhere. He's actually looking at me. He's like, "Are you talking about me?" Anyway, why am I talking about my dog? Oh yeah, because he's an elderly dog now. He's 14 and a half. He's a sweetheart. I love him to death. But he is starting to lose proprioception. So when he walks, sometimes his back feet will scuff the ground because he can't tell exactly where they are. It's related to nerve degeneration at this point in his life. So he will sometimes scuff his feet, or sometimes when he'll get up on a curb, he just will misstep because he can't quite tell where his back paws are at this point. Yeah, he's still mobile and wants to run around and play and things like that, even at his advanced age. But you can tell that he is lacking proprioception because he will sometimes drag his feet and things like that. So that is an ability that human beings have, and we can debate about whether there are other ones. Like I tend to think, I don't know if there's a name for this, but inner ear function is something like a sixth sense. Like I think if we were to put you in a sensory deprivation chamber, so you can't see, smell, taste, touch, or hear anything, and it's like dark, and maybe we were to like knock you out first. This philosophers like to do thought experiments like this, where we think of weird scenarios, and we were to like hang you upside down in a sensory deprivation chamber. I bet you'd be able to tell you were upside down. And not just because, like, imagine we shave your head or something so you look like me. So it's not because like your hair is falling that way. I think you'd be able to tell, just like even if you didn't have any other senses available to you, that you're upside down or like lying on your side. I tend to think, I'm not sure. I don't know what somebody who studies human anatomy or biology. I don't know who the expert would be on that, what they would say. But I kind of suspect that would also be another one, right? So I think we probably have more than 5 senses. So there you go. But that's kind of cheap. That's whatever. That's just for fun to think if we have more than 5 senses. Here's a more serious question a metaphysician might ask. And we're going to spend the most amount of time on metaphysics and then the last branch of philosophy. The ones in the middle we're going to go over a little bit faster, partially because we're going to come back to them later. Here's another question a philosopher might ask. So somebody on the street, I think, thinks that something is real if you can see it, smell it, taste it, touch it, or hear it. Philosophers will also ask, like, well, can you think of things that you can't see, smell, taste, touch, or hear, but you have good reasons to think are real, right? Because that might show you that your standard for telling what's real or not is wrong, is inaccurate, right? That you need a different set of criteria. This is what one of the things that metaphysicians try to do is try to develop standards, criteria for determining what sorts of things are real. And so here's an interesting one. What about numbers? Are numbers real? And I don't mean like the things you write on the board, like Indian Arabic numerals, like 1 or 2. This is probably going to look backwards to you. I don't know if I can do that backwards. There you go. Yeah, 2. 1 or 2. I'm not asking about like the things that you write on a board, right? Because you could also do Roman numerals, V for 5, that kind of thing. I'm not talking about those are symbols. I'm not talking about the symbols. Symbols obviously have a kind of reality. I don't think people dispute that, partially because you can like see them when I write them on a board. I don't mean that. I mean like the numbers themselves. Like what are the symbols referring to? Yeah. So the name Patrick, Patrick Casey, that refers to me. Symbols like this, names like this can refer to things. So like 5, when I say 5, I'm referring to a number. I'm like gesturing. I don't know where to gesture though, right? If I want to say like, I don't know, piece of paper here, piece of paper, right? But 5, I'm not talking about the symbols. Is the number 5, is that a real thing? Number 6, is that a real thing? You might be like, yeah, it is. It's on Sesame Street. I've seen it. It's got big googly eyes and runs around like, stole my wallet. Anyway, it's not like right on Sesame Street. They're obviously real. But I don't mean that. I mean, they're clearly not physical things. You're not gonna like get up and trip over a number in the middle of the night. Like you get up in the middle of the night to get a drink of water. You're not gonna like trip and fall over and be like, oh, I hate it when I leave a number 2 on the floor. Oh, that's the wrong number to pick. Number 4. There we go. I don't know. Anyway, you're not gonna like trip over it in the middle of the night. It's not that kind of thing. So it doesn't have that kind of reality. But why think that that's the only kind of reality? Maybe there's like different kinds of reality. That's kind of the point. They could all be real, but have different kinds of reality. Sound waves are real, and pens are real, but they have different kinds of reality. So ideas seem to be real. What about numbers? Are numbers real? It's another really good topic for a reflection assignment if this is one of the ones that you want to do. I think this one is absolutely fascinating. I'd be curious what you have to say about this, but I will just report. Here's an interesting question. This is a question to ask if you're taking a math class. Ask your math professor if they think that numbers are real. That'd be a really interesting question to ask them. Because I bet that he or she will have thoughts about that. They'll probably be like, they give you whatever they think about this. But as a matter of fact, I believe this is the case, that if you were to survey, you're a sociologist, but if you were to survey mathematicians, my understanding is that many of them, probably the majority of them, I believe it's the majority of them, are actually what are called Platonists, which is to say that they think that numbers are real things. You can't see them, smell them, taste them, touch them, or hear them, but nevertheless they're real. many, I believe it's most mathematicians think that numbers are real things. Maybe I can send you a video, remind me if I forget to do it, from Sir Roger Penrose, who's one of the most important mathematicians and physicists in the world, and he gives a really interesting argument that mathematics are real things. He thinks that mathematicians are like explorers. Yeah, when people went out and explored the globe, like the world is the Earth is a real physical thing, and you actually have to go out and see what's there. And he thinks mathematicians are doing the same thing, partially because you can make discoveries with pure mathematics, just with pen and paper, just by thinking about the relationships between numbers. You can discover things that are true about the real world, like how the planets orbit, which is weird, right? So you can figure things out just with numbers and then go out and test them with things that you can see, smell, taste, touch, or hear, and find out that what the numbers were telling you was true, which is bizarre. That seems to mean that they're not just inventions. It's not like human beings are just making shit up. When they come up with formulae that work, they're actually discovering a real world, a real reality, mathematical reality that you can't see, smell, taste, touch, or hear. That's what many mathematicians believe. Although they wouldn't be the experts on this per se, it would be metaphysicians, so the people who study this kind of thing. But it is an interesting question for mathematicians themselves, because if you work with numbers all the time, at some point you're going to wonder, am I just making stuff up? Like, are we just collectively making things up, or are these things real? And many mathematicians think that they're real, and I think that I know that at least a significant number of philosophers also believe that they are real. So I want to say a better criterion, a better standard for determining what sorts of things are real, and this is not a complete answer, is if they push back at you. If something pushes back at you, then it has a kind of reality. Like, part of the reason why I think that my students are real and not just like figments of my imagination are because like they push back at me, they shove me around when I try to leave. What I mean by push back is like they have a kind of gravity of their own. I'm using metaphors because I don't know how to say this. They have a kind of independent reality. They don't do what I want them to do, right? And part of the reason why I think that my students are real and not figments of my imagination is they don't laugh at all of my jokes. What the hell is up with that, right? If they were just figments of my imagination, then they would think it was funny all the time. And that's just not true. That's not happening. So they have a kind of independent existence, right? I mean, part of the reason I think my house is real is I can't just like push it around. Like, it has a kind of gravity of its own. Like, it pushes back, right? And I think that's true about numbers. You can't just make numbers do whatever you want them to do, right? They will push back at you. They will say, no, that does not work, right? And if you try to take mathematical formulae and put it into the physical world, and those formulae aren't accurate and aren't sound, then the stuff that you will make won't work, right? The house will fall down, the car will blow up, or whatever, right? Hopefully the car won't blow. All right, so that's metaphysics. Lots to think about there, lots to chew on. The next 3 are going to be a lot shorter. So let's move to epistemology study guide, right? Epistemology, second term. Do want you to know this one. We're not going to spend a ton of time on it now because we're going to spend like 2 weeks on epistemology, starting I think next week. So briefly now, epistemology, episteme, right? We talked about knowledge and wisdom. Episteme is the Greek word for knowledge. So epistemology is the study of knowledge. That one's pretty easy. So it's a study of knowledge. So it's a branch of philosophy that studies knowledge. Study of knowledge, epistemology. So logos, the suffix there, ology, when it's used as a suffix, means an account of, or a study of, or a theory of whatever came first. So biology, that's also Greek. Bios is one of the Greek words for life, and logos, a theory of, an account of, or a study of life, right? Biology. Psychology, again, Greek. Psyche means mind. Logos, again, a theory of, an account of, or a study of mind. Psychology, right? So a lot of the disciplinary terms are composites of these Greek terms, and epistemology is no different. So epistemology is a philosophical study of knowledge. All right, so epistemologists study the nature, sources, and scope of knowledge. Nature, sources, and scope of knowledge. So nature of knowledge. What is knowledge? Again, we're going to be talking more about this in the coming weeks. Philosophers thought we had an answer to this for quite a while, and then a guy wrote a paper in the 60s called Gettier, who just like blew up everything that philosophers thought they knew about knowledge. So it's kind of a fun time to be an epistemologist. Or epistemologists like running around like their hair's on fire. That's actually what happened to my hair. I used to have hair, and I became an epistemologist, and it was all over at that point. So nature of knowledge. So we study the nature, sources, and scope of knowledge. So sources of knowledge, we're going to talk a lot about this in the coming weeks. Where does knowledge come from? Does it come from your senses? Does it come from experience? Does it come from your mind? Does it come from reason? Where does it come from? So we'll talk a lot about that. Sources of knowledge. Where does it come from? And we'll talk about the scope of knowledge. So, we won't thematize this one as much, actually. So I'll just mention it now. Scope of knowledge is what are there limitations to human knowledge? And if so, where are they? This is something that philosophers have historically spent a lot of time thinking about. Is what are the limitations of human knowledge, if any? So nature, sources, and scope of knowledge, right? Philosophical study of knowledge. That's epistemology. Number 3, we have axiology. I don't think this one is actually on the study guide. Axiology is spelled A-X-I-O-L-O-G-Y, axiology. So epistemology, right, a study of knowledge. Logos, a study of the first thing. So axiology, study of axes. No, it's not a study of axes. It's a study of hatchets. No, axiology is a study of value, right? That's what it is. It's a study of value. So axiology is a study of value, and there's 2 parts to axiology. So philosophers will study what's called aesthetics. Many of you probably may have heard this term. Aesthetics is a study of beauty. And people who do aesthetics oftentimes study art. And this is something that philosophers have been doing for 2,500 years. Aristotle, if you take a class on art theory or philosophy of art, which I teach here at Holy Family, you'll read some Aristotle, right? Aristotle 2,500 years ago wrote some of the seminal works on aesthetics, especially his Poetics. So if you take a class on like English literature, you're going to be reading the Poetics most likely. So philosophers have studied art. We've studied beauty for really, for thousands of years. And I think I don't do this professionally, like in terms of my own research, although I do teach it. But I think it's so cool that philosophers do this. There were philosophers up when I was in grad school up in New York. They would go to like the MoMA and go to the Met and go to these kinds of places and the Guggenheim and learn about art, literature, poetry, drama, film. Philosophers study all of these kinds of things, which I think is really, really cool. So that's aesthetics, which is a part of a subdiscipline, a sub-branch of axiology. The other branch of axiology is ethics. We will come back and talk more about ethics later in the semester, but for now you can know that it's the philosophical study of morality. Yes, it's a philosophical study of morality. Man, I'm doing this repeating thing. It's ingrained in me. And my dog is dreaming right now. So if you hear somebody wrestling around and yelping in the background, he is not hurt. He's just dreaming. He's so adorable. Anyway, okay. So that's ethics, philosophical study of morality. And we'll come back to that. And that's again all under axiology, the third branch of philosophy. Number 4, we have logic. The root of logic is just logos, right? So logic. Logic is the branch of philosophy that tries to develop methods for distinguishing good arguments from bad arguments. So we're not going to thematize logic in this class. We're not going to have like a logic section, but it's integral to everything that philosophers do, because we try to figure out what's true. And the way that we do that is by dialoguing with one another and offering one another arguments. So studying the nature of arguments is extraordinarily important for philosophers. Logic, though, is profoundly boring. At least I find it boring. It is like the driest subject ever. It is like saltines dry. It's like crackers. They're really dry. Anyway, so it's really dry. But it's also extraordinarily important, not just for philosophy, but also historically. I mean, so when philosophers say, people say that philosophers don't do anything, I always want to talk about logicians with them, because people who did logic in the 20th century completely reshaped the globe, and people don't know this, and it bothers me. So just like, whatever, 3 minutes on this. So people say that philosophers never do anything. I like to say, well, maybe except for the inventing computers. That's a big one. So philosophers developed both the software and the hardware that was then used to develop computers. So I've taught logic before, and when I teach logic, I taught logic at a research institution up in New York, and my students were like, wait, this is like computer science. And I was like, well, no, it's the other way around. Like, computer science is just based on logic, right? The people who did this type of stuff, who were logicians, especially in the late 19th and early 20th century, mathematicians and logicians were like really closely interlinked at this point. So many people who were logicians were also mathematicians, and vice versa. So people like Boole, people like Russell and Frege, people who developed what's called symbolic logic, they developed this symbolic language that was then used to program computers, right? So they developed the logical operators that we now use to program computers, amongst other things. So they developed the software. That's an important thing to be aware of. So, which is cool, because logic hadn't really changed for like 2,000 years after Aristotle. Aristotle wrote logic 2,500 years ago, and it didn't really change, to the point that Kant in the early 1800s was like, logic is a closed canon. Like, everything that we know, everything that there is to know about logic is like we already know it. And that turned out not to be true. Late 19th century, early 20th century, just huge explosion in development of artificial languages, basically symbolic languages, took place because of logicians and mathematicians who were studying these things, and that gave rise to computer languages. Hardware, too, was also developed by a student of a logician. So there's Alonzo Church, who was a logician out in California for most of his career. He is actually my philosophical grandfather. The guy who advised my dissertation studied under Alonzo Church. One of Alonzo Church's other students, one was Gary Marr, who then was my advisor, my PhD advisor, but one of Alonzo Church's other students was Alan Turing. If you don't know the name Alan Turing, you should know the name Alan Turing. If you're interested in AI, you might be familiar with the name, but you should be familiar with the name just as an informed citizen. Alan Turing is one of the most important intellectuals of the 20th century, and he is one of the first people to develop essentially the hardware that was used for a computer. So during the Second World War, you can watch a movie called The Imitation Game, which is, I think my understanding is pretty accurately depicts Alan Turing's contributions during the Second World War. He was in England at the time, and worked in what's called Bletchley Park, something like that. I might be mispronouncing that. But he was hired by the English government to be a code breaker, and they were trying to crack the Nazi Enigma code, which is the code that Nazi high command used to send communications to one another. And Alan Turing was hired as a code breaker because he had studied logic, and he was well equipped to do these kinds of things. But he realized pretty quickly that there's no way that they were going to do this with pen and paper. The Nazis reset the code every day, and there's like how many tens of billions of potential codes that could be developed, could be used any day. And he's like, there's just no chance. There's not enough time in a day for us to crack this code. We would need like many millennia, like thousands of years to crack a code on any that resets every day, right? So they only have 24 hours. They don't have many thousands of years. So what he did is just like, I think we need to develop a machine which can help us do this. And people thought it was just ridiculous, but he did. He developed one, and did crack the Enigma code, which is insane. So that the Allies during the Second World War towards the end of the war, were able to read the messages from Nazi high command, which is absolutely insane. Historians have estimated that Alan Turing's contribution here, his team, to cracking the Enigma code, shortened the war by 2 years and saved more than 10 million lives, I believe is what they've estimated. That's insane, right? So philosophers not only developed the computer software, they also developed the hardware that then were used to make computers. So there you go. Logic may be boring, but is it extraordinarily important, extraordinarily powerful. All right, and last thing we have is the history of philosophy. We're going to spend a little bit more time on this one too than the earlier ones. History of philosophy is a branch of philosophy that studies the history of philosophy. I don't really know what else to say. That's what it does. Anyway, history. All right, so let's talk a little bit about it. So philosophers are one of the few disciplines to study our own history. Most disciplines don't study their own history. That's not just like what they do. So, I mean, like, historians, I guess, do, but other people don't. Like, biology professors, I don't know, I keep on picking on biology professors. Bio professors, chem professors, physics professors, they're not going to tell you about, like, the history, really, of chemistry or physics. Maybe a little bit. They might mention Newton or something like that, right? But they're not going to give you the whole history of their disciplines. If you want to know about the history of intellectual inquiry, you really have to talk to, historians or philosophers, because we're the gatekeepers of these kinds of things. We still study, ancient texts like they're breaking news. Like, grad students will still be walking around reading Plato's Republic. And like, this is amazing. This is incredibly insightful. And I wish more people did, because I was just listening to NPR the other day, and they were like, oh, breaking, cutting-edge scientific research in dietary science tells us that human beings actually have 3 parts. They have appetites, then they have emotions, and then they have reason. And I was like, that's not breaking news. That's from Plato's Republic. It's book 4 of the Republic. He says that the soul has 3 parts, and it has those 3 parts. Anyway, so there's actually kind of like eternal, perennial truths to be pulled from philosophical texts. So we still read them, right? So we still read stuff. Like when I was an undergraduate, I still read. I read Galileo, like I read Newton, I read Kepler, I read these actual people, not just like little paragraphs about them, in a physics book. I actually read some of the stuff that they wrote. And so if you want to learn about the history of ideas, really you have to talk to historians or philosophers. So if you've taken a class on chemistry, you probably know about oxygen, in the atomic table or whatever. But you probably don't know about phlogiston. You can look that up. It's spelled with the PHL, starts with the PHL, phlogiston. That was the old theory of how they explained combustion before they came up with the theory of oxygen. And again, they're probably not going to talk about this in chemistry class because the job of the chemistry professor is not to teach you about the history of chemistry. It's really not. Like, I'm not faulting them. I don't think they're doing something wrong. Their job is to train you to do chemistry, not to understand the history of the discipline. If you want to learn about the history of the discipline, you got to talk to philosophers and historians, right? Their job is to train you how to do chemistry so that when you graduate, you can like get out and make get a job as a chemist and like make drugs for the rest of us, crystal meth or heroin or whatever. I don't know, break bad. I don't know, Benadryl, whatever you're going to make. Actually, isn't that part of meth? Doesn't matter. It's not important right now. Anyway, that's not their job, right? So one of the things you'll learn if you study, history of ideas, if you do the history of philosophy, one of the things you'll learn is that, amongst other things, the word scientist did not exist until 1834. This is something that I want you to know, right? The word scientist did not exist in the English language until 1834. How about that? So before 1834, there were not scientists around, right? We tend to use that word when we talk about Newton. We're like, Newton the scientist. He was not actually a scientist. He didn't call himself a scientist. In fact, his major work mentions not science, but something else. You can read the title, right? So what do you think they might have called scientists before 1834? You're in a philosophy class. It's like the Sunday school answer. If you don't know the answer in like Sunday school, you're just like, Jesus? That's always like, who parted the Red Sea? Like, Jesus? No. Like, where your head's at, but no. In this class, if you don't know the answer, philosophy. Yeah, they call them philosophers, and specifically they call them natural philosophers. This is something I want you to know. Before 1834, we're not scientists. These people were called natural philosophers. There are other names, but the primary name for them was natural philosophers. So if you got into a time machine, went back, talked to Galileo, and you'd be like, what are you and your scientist buddies up to? He would have been like, I don't know what you're talking about. Primarily because he spoke Italian, not English, so he wouldn't understand what you're saying. But also because, anyway, there was not an English word for scientist at the time, even if he spoke English. Not an English word for scientist. In fact, the term scientist was invented by a philosopher in 1834. This is not just a terminological thing, though. Newton and Galileo were not scientists in our sense. They were natural philosophers. Natural philosophy was a broader discipline. So this is not just like a linguistic thing. I'm not just like, they were actually called philosophers. Didn't know that. Did you? It's not just that. I am kind of an asshole about these kinds of things. But it's not just that. The natural philosophy was different than what we call science today. Natural philosophy was bigger. It included, amongst other things, now I can say this term and you should know what it is, it included metaphysics. It included talking about God, for example. Natural philosophy was totally normal to talk about God, right? So if you go back and read Newton, you read Kepler, you read Copernicus, these people talk freely about God being involved in the natural world, right? Kepler, in fact, thought, he was one of the first people who believed that the sun was at the center of the solar system, and Kepler said the reason why he believed that is because he thought that the solar system was a symbol for the divine Trinity, the Holy Trinity. Yeah, he was a Lutheran, he was a Christian. And he thought that the sun at the center of the solar system represented God the Father, and the stars represented the Son, S-O-N, Jesus, and then the space between represented the Holy Spirit. So yeah, part of the reason why he believed that the sun was at the center of the solar system is because he thought that that was a fitting place because the sun represented God the Father, right? The earth shouldn't be at the center of the solar system, the sun should be, because that's where God sits on his throne, illuminating all of the cosmos. This is Kepler, right? That's not science per se. That's natural philosophy. Natural philosophers are like, that's an interesting argument, right? Whereas a scientist, if you were trying to publish something like that in a science journal today, good luck. You're like, so I believe in dark matter because Jesus. They're going to be like, no, this is not science, right? But you can do that in natural philosophy because natural philosophy was a broader discipline. It included things like metaphysics. Science is a much narrower discipline. In fact, part of the power of science comes from the fact that it shed questions of metaphysics. It narrowed itself. Science doesn't actually discuss very much of the universe. It only discusses things that you can see, smell, taste, touch, or hear, right? Whereas metaphysicians don't discuss just those things. We also talk about souls. We also talk about free will. We also talk about God. Science is very narrow in its scope, and it's like focusing light. It's like a laser, right? A laser is like focused light. That's why science is so powerful. Is because it's very, very narrow in its scope. Right? Philosophy is not narrow in its scope. But historically, all of these different disciplines, interestingly, were originally nearly all of them were originally part of philosophy and branched out. So you can think of inquiry through time as being like a tree, and then the different branches are like the different disciplines that broke away from philosophy. So, psychology was originally part of philosophy, chemistry originally part of philosophy, physics originally part of philosophy, and all these different disciplines broke away eventually from philosophy. So, unfortunately, it gives people the impression that philosophers don't do anything. Aside from inventing computers, philosophers are also responsible for nearly every other discipline that exists. Yeah, so biology, physics, chemistry, psychology, all these kinds of things. Sociology was also developed by a philosopher, Auguste Comte. Nearly all of these other disciplines were developed by philosophers. So it gives people the impression that philosophers never do anything. But the real truth of this is that philosophers keep those questions, that we don't have agreed upon methods for settling disagreements in this field of inquiry, right? So a better way to think about a science is that a science is when you have it's not like, science is discovering the truth. Many of you now know this because of the coronavirus pandemic, that you've actually seen the sausage being made with science, and you realize that scientists disagree with one another a lot, and they think one thing on Tuesday and then decide they were wrong on Thursday. So science is not about pinning down infallible truth, right? That's not what science is. Science provides the best account of something that we have right now, and the idea is that science progresses over time and it gets better over time, and so frequently they decide what they thought yesterday was wrong. It happens all the time, right? So you should always be taking things that the scientists say with a grain of salt, right? It's kind of the idea, knowing that they're actually probably going to do better next week. Right? It's not an insult to the sciences. Like, I love science, but the coolest thing about science is that it gets better. That's the coolest thing about science. But if it gets better, that means that stuff in the past is typically worse, right? So stuff today, people in the future are going to know better than we know today. So you should always be, take what scientists say kind of, you should take it seriously, but you should also hold it somewhat lightly, because it is the case most likely that people are going to discover something new in the future, which is going to contradict what they think today. This has just recently been a debate in psychology. Some of you may know this. There's a paper published that said that depression is not actually caused by serotonin imbalances, which has been the prevailing way of thinking about what depression is for the past several decades, which is why they medicate people for depression. They give them serotonin reuptake inhibitors. And then this paper is suggesting that may not be true. That's important to know, right? So something we thought that we knew, we turn out we might not know. Yeah. So this is the way the science is. It progresses. It gets better over time. So what it is to have a science is not dependent on infallible truth. What it is to have a science is to have an agreed upon method for settling disagreements in a certain domain of inquiry. This is how I like to think about it. This is not a complete account of the science, but I think it's a really helpful way of thinking about it. A science is, when you have a science, it's not pinning down infallible truth. It's having an agreed upon method for settling disagreements in a certain area of inquiry. Scientists disagree with one another all the time, right? Scientists disagree with this paper. Some psychologists are like, no, that paper can't be right, about depression. And so they hash it out. The way they hash it out is they have an agreed upon method. Yeah? That's what makes it a science. So people disagree with one another. It's not truth that makes something a science. It's an agreed upon method predominantly, and an agreed upon body of knowledge and standards. There's more to it, but this is one of the cornerstones. So when scientists disagree with one another, psychologists disagree with one another, it's not like one person goes out and does a survey and the other reads tea leaves. Those would be two different methods. They have an agreed upon method, right? And so different sciences have different methods. This is why if you get a degree in chemistry, you can't then be a psychologist, right? But I have a degree in science. Like, yeah, but chemistry is very different than psychology. Yeah, if you have a degree in psychology, you can't just go out and become a pharmacist, because not the same thing, right? You learn very different methods, learn very different bodies of knowledge. What you have is an agreed upon method. So you can see this. When there's a disagreement, you can pay attention to how scientists try to settle the disagreement. So here's an interesting one. To give you a sense of what this is like, sociologists, they disagree about this following question. Who has more sex? Is it single people or is it married people? And we're almost done. Yeah, but who has more sex, single people or married people? Really interesting question. So there's disagreement. Some sociologists were like, oh, it's got to be married people. Some sociologists were like, no, it's got to be single people. Well, they have a method for settling that disagreement. They get swords and they fight to the death. No, that's not what they do. They do surveys, right? That's kind of the method, part of the method. They also do statistical analysis. It's very sophisticated. Right? When the sciences broke away from philosophy, it's because they developed their own method, right? Or philosophers developed a method and then we gave birth to a science. That's actually the right way of thinking about it. But they go out and they do surveys, and they've actually studied this one. So you can look this up. National Sex Survey, 5,000 participants at the University of Indiana, which is like a huge orgy. Lots of cameras. Anyway, inappropriate. No, but they did. They surveyed lots and lots of people, and they tried to figure out who has more sex. That's one of the questions they had. Who has more sex? Single people, married people? You know what the answer is? The answer is married people have a lot more sex than single people. This may be surprising to you. It's usually surprising to students, but it's not even close. And you just have to think about it for a second, because I think that students, when they think about who has more sex, single people or married people, when they think about married people, they're thinking of somebody who's like 60 and it's like kids or whatever, and it's like, retired or something. And when they think of like a single person, they're thinking of like some 20-year-old. But if you're just trying to isolate the variable of single versus married, you have to isolate that single variable, right? You can't compare. You have to compare apples to apples. You can't compare apples to really old oranges. Like that doesn't work, right? You can't compare like a 20-year-old to a 60-year-old. No. If you want to figure out who has more sex, single people or married people, you have to compare not a 20-year-old single person in college with a 60-year-old who's married. You have to compare them with who? A 40-year-old who's married? No. Oh, a 20-year-old who's married. Oh, right. Yeah. Oh, right. Okay. So who do you think's having more sex, a single 20-year-old or a married 20-year-old? Now it's obvious. Married person's having a lot more sex at every age bracket, incidentally. Yeah, I mean, it's like not even close. Right? The same thing. I think what people have in mind is partially they think of an old person, they think of somebody who's married, but also there's something that's highly correlated with marriage, which is not marriage, which will lead to lower levels of sex. You think what it is? Kids. Yeah, kids. Having kids will decrease your sex life significantly. But then again, who do you think's having more sex? Is it, again, if you're just trying to isolate the variable married versus single, then you have to compare the single person with kids to the married person with kids. And again, who do you think's having more sex? The married person is. Right? If nothing else, it's because, if you're like single, you gotta go out and try to pick somebody up at a bar. That's like hard, man. Unless you're like Chris Hemsworth, Thor. I think he's actually Thor. I don't think he's an actor. I think he's just actually Thor. Yeah, anyway, just call him Chris Hemsworth. Anyway, unless you're like Chris Hemsworth, your chances of picking somebody up at the bar being successful aren't that high, right? So you're like, what are you doing? Right? May not work. But if you're married and you're just like whatever, sleeping next to somebody every night, you're like late at night, like reading or whatever, you're like, what are you doing? I'm not doing anything right now. Your chances of success are going to be higher. Anyway, so science is an agreed upon method for settling disagreements in a certain domain of inquiry. That's what it is to have a science. So they will answer these questions, and those questions can change over time, but that's what it is to have a science. And again, what philosophy does is when we develop a method for settling answers in a certain domain of inquiry, we give birth to a science, right? So when, Auguste Comte made up the methods for sociology, he developed the kernel, which has been developed into a full discipline. They gave birth to sociology. Psychology, again, originally part of philosophy, biology, and so on. What philosophy does is it keeps those questions, and we're in the last minute here. Philosophy keeps those questions which we don't have agreed upon methods for settling. So, for example, we don't have agreed upon methods for settling questions like, does God exist? Do human beings have immortal souls? Is abortion morally permissible or is it not? We don't have agreed upon methods. Like, what's the method for determining whether or not God exists? Good luck with that. We don't have one. So the best method that philosophers have is argument. That's why logic is so important. But we get together and we discuss things with people, predominantly with people who disagree with us, so we can challenge our ideas and we can try to separate the wheat from the chaff, the good arguments from the bad arguments, the good positions from the bad positions. And this is what philosophers do, right? So philosophy, if it has something like a method, it's basically argumentation. All right. So philosophy has historically been really, really important. It's given birth to lots of to pretty much all of the rest of academia. It's also important because it's given rise to computer languages. But this is what philosophers as an academic discipline do. We typically partake in at least one of these 5 branches of philosophy, usually more than one at a time. But we do metaphysics, epistemology, axiology, logic, or history of philosophy, or some combination of those 5. All right. So that's the academic discipline of philosophy. You made it. This is one of the longer videos. Have a good day.